Well, hello. Today we're going to start Chapter 11, talking about the first section of Chapter 11. Chapter 11 is all about conservation of energy, and so before we can talk about conservation of energy, we're going to talk about the different forms of energy. So let's just review a little bit about what we learned in the previous chapter concerning the relationship between work and energy. We know that work causes a change in the energy of the system. And we know this from the WorkEnergy theorem. And so there's two ways that energy can be transferred. So work can transfer energy between a system and the external world, and it can be either positive or negative. Energy can be transferred from or transformed from one form to another. So the main forms that we're going to discuss are kinetic and potential energy, but we can also have heat and other forms of energy as well. So energy is always just transformed because it is conserved, and so it's never lost completely, it just goes to a different form. We know that work and energy are related through the work-energy theorem. So if work is done on a system, then the energy of the system increases. And we talked in the previous chapter about how this was positive work if the work was done on the system. If the system has to do work, or if work is done by the system, then the energy of the system will decrease, or this would be negative. Energy can be stored or spent, and that's kind of what we're going to talk about with the relationship between potential and kinetic energy. Alright, so our first type of energy we're going to discuss is kinetic energy. We've already talked about the relationship between work and kinetic energy. So kinetic energy is equal to 1/2 times the mass times the velocity squared. So it is proportional to the object's mass and the square of the object's velocity. Stored energy is our other version of energy, and energy can cause motion when it changes from one form to another. So if you think about a boulder sitting on top of a hill, it has stored energy initially, and when it starts rolling down the hill, it is now in motion and is changing from stored to energy of motion or kinetic energy. So you could also have a vehicle at rest and then moving. We talked about the boulder example, a jack-in-the-box, lots of different examples with this transfer of energy. So we have kinetic energy, and then we have stored energy, which is also known as gravitational potential energy. So this is stored energy that occurs as a result of the gravitational force between the object and Earth. So usually, or especially if it has to do with gravity, this is going to be vertical. So a boulder rolling down a hill, gravity is causing it to roll down the hill. Holding a pen up in the air and dropping it, anything like that is going to be as a result of gravitational potential energy. When you do problems with gravitational potential energy, it's important to choose a reference level. Now, usually this is the ground, but it doesn't always have to be. It's a position where potential energy is defined to be 0, so you can set it at any height that's convenient for solving the problem. So, for example, if I have a pen resting on a counter that is 5 meters above the ground, then that would probably be my reference level, and then if I lifted it or lowered it from there, that's how I'm going to determine my potential energy. So you really have to think about what the problem is asking and the situation involved to choose your reference level. The equation for potential energy is mass times the acceleration due to gravity times h, which represents height. And so that's because this is due to gravity, and so we have to involve height as part of our calculation. We also have what's called elastic potential energy. Kind of think about when we talked about momentum, when we had elastic collisions where the objects collided and then bounced back. So this could be the total energy, stored energy in a pulled string. Rubber balls, rubber bands, slingshots, and trampolines would also be considered as objects that could have elastic potential energy. So basically you can pull them and then they will return to their original shape and won't be deformed. A lot like an elastic collision. Okay, rest energy is also a type of energy, and this was recognized by Einstein. And basically he said that mass has energy or is energy. And so this is where we get the E equals mc squared, where c represents the speed of light and m represents the mass, and those together do have energy. Alright, so this is what we're going to do in class, but please feel free to take a look at them on your own beforehand. And then this is the homework that you will be working on along with the answers. Have a good day.